In the solar system closest to our own, strange things have been going on. Only 4 light-years separate us from Proxima Centauri, and for longer than that, astronomers have been noticing some peculiar signals on a planet in the system, Proxima B. The most brilliant minds in the space community have been rattled by these strange anomalies, known as artificial lights. What are they, though? Does this suggest that there is intelligent life on the planet? Do we have another civilization in our interstellar neighbourhood? Late in 2020, a signal from the direction of Proxima Centauri, our nearest neighbour star known as BLC One, was found. To make sure the signal isn't just an echo of our own civilization, which is usually what they turn out to be, it is still being analysed. So why don't we simply examine the planets in Proxima Centauri to determine if there is a civilization there? From space, the glow from our planet's night side is the most obvious indication that someone lives on here. Light from our cities is emitted into space. The issue is that the telescopes of today's generation lack the power to detect lights on other solar systems. However, a number of scientists are currently evaluating the capabilities of the already conceptualized next generation of telescopes. We are looking at you, James Webb. What conclusions were drawn? Yes, if technologically or luminously advanced enough, we might be able to tell if Proxima Centauri is home to another civilization. A recent study on techno-signatures raises the likelihood of our ability to detect artificial light on Proxima B. According to what we know, the planet's mass is comparable to that of the Earth, and it is in the habitable zone. Furthermore, because it revolves around the nearest star, we can naturally expect to learn a lot more about it as a result of new technology, particularly the James Webb Space Telescope. A multi-wavelength space-based observatory with a potential to launch in 2035 is the LUVOIR, or Large UV Optical IR Surveyor, which is another focus of the new study. The authors, Elisa Tabor of Stanford University and Ava Loeb of Harvard University, notes that artificial lighting would be required on a tidally locked planet with a permanent night side in order to sustain a technological culture. This is one of the longest of long shots because it is incredibly unlikely that civilizations growing around nearby stars will coincide. On the other hand, a civilization that emerges elsewhere might be identifiable by the artifacts it leaves behind on the planet it has chosen to explore. There are a few ways to identify the presence of alien technology on another planet. With a vast constellation of satellites, we might be able to observe, for instance, how the light of a far-off world wanes. The same things, that also take place on Earth. With the growing number of satellites we launch into orbit, atmospheric pollution from nuclear war may be visible. Even though these technological signs could also be brought on by a comet impact or orbiting debris, artificial light is different from the starlight. Last year, researchers Elisa Tabor and Ava Loeb, who have already been mentioned, went virtual alien light hunting on the Webb. But because it isn't yet fully functional, the results were a little shaky. The Proxima B planet, which is the only confirmed planet in the Proxima Centauri system and is 4.25 light-years away from Earth, is the target of the JWST. A rocky planet called Proxima B is located in the habitable region of Proxima Centauri, an M-class red dwarf star. The mass of our Sun is only 12% smaller than that. Proxima B has a radius that is 1/3 our size and about 1/6 the mass of Earth. It travels 7 million kilometers, or just 5% of the distance that Earth travels around the Sun, in just 11.2 days to complete one orbit of Proxima Centauri. Artificial lighting was scaled by Tabor and Loeb as a portion of the solar illumination that our planet's day side reflects. On this scale, 0% implies that the planet's night side is completely dark. 100% would imply that the planet's night side and day side are both equally bright, which is also not conceivable. It is assumed that the hypothetical civilization on Proxima B uses a type of light similar to Earth-based LEDs, which are clearly artificial in nature. What have we learned thus far, then? The Webb could identify the artificial light with an accuracy of 85% if Proxima B's artificial night-side illumination reaches 5% of the natural day-side illumination. Webb's detection rate would increase to 95% if artificial illumination were to reach 9%. 5% illumination doesn't sound like much. I know what you're probably thinking. In contrast to our Sun, which is about 20 times fainter, the light from Proxima Centauri is about as bright. Similar to setting a firefly next to stadium lights, that. However, even that much light is substantial on a cosmic scale. In contrast, only 0.001% of the reflected stellar illumination is represented by artificial lighting on Earth. In other words, the Webb would not be able to detect a civilization on Proxima B that is as lit up as ours. 500 times more brightness would be required for those lights. That situation is conceivable. As we've previously mentioned, Proxima B's orbit is so close to that of its host star that it may be tidally locked, with one side of the planet always facing the star and the other experiencing perpetual night. A tidally locked planet's civilization would likely need to concentrate on developing its lighting system, and it may use extremely bright orbital mirrors to reflect sunlight onto the day side of the planet, which could be seen by our telescopes. But of course, that's just theory. According to Tabor and Loeb's research, other telescopes in the future, like Louvois or the Large UV Optical Infrared Surveyor, may be even better than JWST at spotting the glow of an extraterrestrial civilization. Thomas Beattie of the University of Tuscan's Department of Astronomy provided those numbers just a few days after the researchers' publication to support their claim. In order to understand how these telescopes will detect city lights on planets orbiting stars out to a distance of 30 parsecs, or PC, Beattie reviewed both Louvois as well as HABEX, or Habitable Exoplanet Observatory. One PC is roughly 326 light-years away. There is still a long way to go before HABEX and Louvois, which are both set to launch in 2035, catalogue and directly image exoplanets. On a number of star systems with known planets, such as Proxima B, as well as hypothetical Earth-like planets orbiting GK and M-class stars, Beattie used virtual replicas of Louvois and HABEX observatories. A portion of the planet's surface that was urbanized was also scaled by Beattie. The night side of the planet is brighter the more urbanized the area is. The type of artificial lighting used in this model mimics high-pressure sodium streetlights that reflect off of concrete surfaces and have a spectrum that can be distinguished from that of stars. These lights are the most prevalent lights on Earth. Therefore, the variables are the planet's distance from Earth, its degree of urbanization, and the kind of star it orbits. For a minimum of 100 hours in each scenario, the virtual scopes image planets in order to gather enough light coming through the void to resolve the target. Only about 5% of the surface of the Earth is urbanized. If someone were to look at us through a telescope from Proxima Centauri, they wouldn't be able to see us. We might be able to see a faraway civilization more clearly if there were more people living in cities, say 100% more. But what does 100% urbanization actually mean? That is referred to as ecumenopolis. A city-planet, or ecumenopolis, is a planet with a single enormous city spanning its entire surface. It sounds incredibly science fiction, I know. The best part is that there are already a number of examples, such as the ecumenopolis planet type in the space strategy video game Stellaris, or Coruscant, the capital of the Republic Empire in Star Wars. However, it's more likely than not that a highly developed civilization could completely enclose their world in an endless urban landscape. How obvious would that world be then? Future telescopes would be able to find ecumenopolis worlds around 82 stars close to the Sun, according to Beattie's model of the outcome.